What if your mind could control a computer as seamlessly as moving your hand, or retrieve information from the internet without ever typing a word? This isn't the plot of a sci-fi movie. It's the frontier of brain-computer interfaces, BCIs, and Neuralink is one of the boldest players aiming to fuse human biology with digital technology. Are we on the verge of a revolution that will redefine how we communicate, work, and even think? Let's find out. Welcome to Brought to You by AI, your channel for exploring the most transformative tech of our time. Today, we're diving into Neuralink, an ambitious project spearheaded by Elon Musk. Their goal? Create tiny implants that read signals from the brain and translate them into commands for computers, prosthetics, or even advanced robotics. Imagine regaining mobility after paralysis or controlling digital devices with nothing but your thoughts. In the next few minutes, we'll unravel the science behind Neuralink, the potential it holds for medicine and daily life, and the ethical debates that come with tapping directly into the human mind. What is Neuralink and how does it work? Neuralink is developing ultra-thin threads, thinner than a human hair, embedded with electrodes designed to detect electrical impulses from neurons in your brain. These threads connect to a small, coin-sized device surgically placed in the skull. Through these electrodes, neural activity can be recorded or stimulated. The idea is to bridge biological signals and digital code, enabling two-way communication between the brain and external systems. Other companies have worked on brain-computer interfaces for years, but Neuralink's innovation lies in making the hardware smaller, more flexible, and potentially safer to implant. If perfected, this technology could enable humans to navigate software, text friends, or even play video games purely with mental commands. Medical applications and early trials. The first big leap for Neuralink is medical. Millions of people suffer from conditions like paralysis, spinal cord injuries, or neurodegenerative diseases. A refined BCI could bypass damaged nerves, giving individuals the ability to control prosthetic limbs or communicate via on-screen text simply by thinking of certain motions or letters. In early demonstrations, animals with Neuralink implants have reportedly been able to interact with computers in real time. While clinical trials in humans are still at an early stage, the results could redefine rehabilitative medicine and open the door to a world where brain injuries no longer mean a total loss of independence. Potential daily uses and transhumanism. Beyond medical applications, Neuralink hints at a future where everyone could opt for cognitive enhancements or hands-free control of digital devices. Instead of tapping on a smartphone, you might silently direct a virtual assistant to draft an email or navigate your smart home. This ushers in the concept of transhumanism, using tech to amplify human abilities. Imagine heightened memory, direct mental access to online data, or multitasking across both physical and digital realms simultaneously. It's a thrilling yet contentious vision. Are we ready for a world where the line between human intelligence and AI blurs? Risks, ethics and regulations. Invasive brain implants raise significant ethical and practical questions. Surgery on the brain, no matter how minimally invasive, carries risk. Data privacy becomes paramount. If a device can read neural signals, could it also be hacked to extract our innermost thoughts? Then there's the prospect of socio-economic divides. Will only the wealthy afford advanced cognitive implants, potentially creating a new form of inequality? Government oversight is crucial, ensuring that BCIs meet rigorous safety standards. Experts also worry about responsibility gaps. If an action is triggered by an AI-connected implant, who's truly at fault for mistakes or accidents? These unresolved issues mean that while Neuralink's tech sparks excitement, it also demands a robust ethical framework. Conclusion. Neuralink offers a glimpse into a future where human brains and computers merge, tearing down barriers once deemed permanent, like paralysis or locked-in syndromes. Yet, it also raises profound questions about identity, privacy, and the essence of what it means to be human. Do you see BCIs as humanity's next great leap, or do the risks outweigh the rewards? Drop your thoughts in the comments. If you found this discussion enlightening, hit subscribe and join us for more deep dives into the tech that's reshaping our world. This is Brought to You by AI. Thanks for tuning in, and see you next time.